continuing on week 9, we have some more examples from Dr. Bob's notes to accompany introduction to vibrations with applications. Vibrations. I'll leave out the one. There should be a one right here. One. So we have an 800-pound single cylinder vertical compressor. There's a piston inside there. Okay. So he's compressing air, making compressed air, or it could be refrigerant compressors. And he's so his weight is equal to 800 pounds, and he operates at an omega F. It's not a W. 1200 RPM, 2 pi over 60 to turn it into radians per second. So 125.7 radians per second. Great. And it's got an imbalance force, FO, of 25 pounds. And it is desired to reduce this force so the output we want is 3 pounds from the support base. We'll draw it as 2, but we're just going to look for a single K. What is the total stiffness required for this design? What would each individual string be if it was supported by 4 corners, right? So there's going to be 4 stiffeners in parallel, so they're going to add together for a total stiffness. So we'll find the stiffness required, and then we will divide it by 4 and to get the answer. All right, so the TR that we're trying to find is FT over FO, which is going to be 3 pounds over 25.120. The equation we should use, they don't talk about damping, so I assume undamped. And we can go ahead and use this version of the equation. We might want to find the natural frequency first. I waited actually this time. I generally would find it right away. So let's go find it. Get some points. Saw a couple people that were struggling on the exam recently, and they could have gotten some points for the writing down the natural frequency of the thing. Oh, we don't know K yet. That's the reason why. Okay, so let's wait a little bit. I misremembered how to do this problem. So the transmissibility is 1 over r squared minus 1. All right, so that should be the absolute value of it, by the way. So we'll take the r squared minus 1 is equal to 1 over the transmissibility, which ends up being 1 over 0.1212, which equals 8.333. And you can see that, oh, we're just going to add the other side, and we're going to get an r. It wouldn't make any sense to have this plus or minus, so we don't really even need that, do we? So we take the square root of 9.333. It ends up being 3.055. And so now we can put together, now we use this right in there. So we know that first off, let me write this down. We'll get that since R is equal to omega F times omega N, that omega N is equal to omega F over R. I do that right? Sure. And we know omega F, and we know R, so we know that it's going to be 125.7 divided by 3.055. So now we have the required natural frequency for this transmissibility, which is resulting in the 3 pounds. And so now we can take this, we went down to there. Let's change colors to light blue. We'll say that 41.15 is equal to the square root of K unknown divided by mass, but of course this is 800 pounds, so we need the 32.2 up there. And if we do that, we can get the K equal to 42,060 pounds per foot. And then, therefore, we could divide by 4 and get 10,520 pounds per foot. But actually, springs in US units should come in pounds per inch, so we would actually want to divide that by 12 and get 877 pounds per inch. And then so we would look that up in the spring catalog to attempt to find a spring we could buy, 4 springs we could buy to accomplish this desired design goal. We will move on to the next